Good morning, students, and good afternoon on this beautiful fall day in November. We have a lesson today about absolute value inequalities. We'll start, as usual, with our do now. I want you to thoughtfully answer a great question about your personality, abilities, and skills. Our objective today will be to solve and graph absolute value inequalities, and we will write our answers in interval notation. So we're going to solve, graph, and write in interval notation. And our essential question asks, how can we solve absolute value inequalities? And how are absolute value inequalities like compound inequalities? We'll watch today's video and we will complete problems number 1 to 10. Our exit ticket asks us to fill in a blank today. Absolute value inequalities are blank inequalities. Less than inequalities are like the blank type, and greater than inequalities are like the blank type of compound inequality. Our homework today will be absolute value inequalities, and there are 14 problems. Remember, I want you to please check PowerSchool for missing assignments. I have updated everything in PowerSchool. Quarter 1 is nearly complete. Let's get those grades up. Let's get that, makeup work turned in. On Tuesday, I will collect all the beautiful homework you've been doing for Unit 2. We'll do it via photograph since you are now in a distance learning mode already. I had planned that if we're in school, you could give that to me hard copy, and if we are back in school, that's always available to you. So also make sure you study and look forward to that test on Tuesday, November 10th. So remember, sometimes you need to look very closely to find the answers you need. And I hope you find all the answers in today's Do Now and in today's lesson. I know you'll be great. So our Do Now today asks us to take a moment to recognize and describe the following aspects of yourself: your personality and your abilities and skills. So those are two different things. You could be someone who's very funny, but that doesn't necessarily mean you have a skill in writing comedy sketches or in stand-up comedy. Maybe a skill of yours is writing short stories or being a good friend to others. Maybe my personality is I like to get things done, but a skill I have would be to organize my task list in order to be more accomplished. And then we ask, are these characteristics fixed over the course of your life, or can they change? Fixed means unchanging, okay, very staid and in one place. So it would be the opposite of something that changes. So please take a minute and think about that and write a couple words about that. And as promised, here is our exit ticket, and we will get back to that later. So our topic today is absolute value inequalities. And what we are going to do today is we're going to put together the skills we have with solving absolute value equations and the skills we have with solving inequalities, and we're going to put it all together. So let's get started. I have another paper ready for us. We can look at it, and this is our topic for today. So we have these absolute value inequalities, and they come in two cases. My highlighter ready. So case one are the greater than or equal to type. And here I have my first example. I have the absolute value of x is greater than or equal to 3. So just like I do with an absolute value equation, I make two cases, right? So I have x is greater than or equal to 3, but here's where we do things a little bit different. We want to keep the first, sorry about that, we want to keep the first variable. Then we're going to switch the inequality, and then we're going to switch the sign on the constant on the second inequality. Okay, so what did we end up here? We ended up with K, I, S, S. Keep it, switch, switch. So we've kept the first, the variable. Then we switch the inequality and we switch the sign. So that leaves us with x is greater than or equal to 3, x is less than or equal to -3. When we graph it, here's our x is less than or equal to -3. On this side, open circle. Well, that should be closed. Let's fix that. We have, there we go. X is greater than 3 on this side. We'll highlight that so you can see it. Now we have our interval notation as well. We have our open parentheses, so I'm going to change that because I guess I thought I was working with less than, not less than or equal to. So let me fix that really quickly for you. That should be a bracket, and I hope you noticed that right away. So I have my open parenthesis, -infinity, comma, -3, bracket, or bracket 3, comma, infinity, open parenthesis. So that's really it in a nutshell. But those are the greater than or equal to cases. So we'll call those case 1. Okay, so look at the direction of the inequality first. Case 2, we have our less than or equal to cases. So in this case, we've got our absolute value of x is less than or equal to 4. So first we can remove the absolute value bars and make our two cases. In our first case, x is less than or equal to 4. We don't change anything. Then we apply KISS. We keep the variable, switch the inequality, switch the sign on the constant on the right. So now we have x is less than or equal to 4, x is greater than or equal to -4. And here's our graph with a closed circle on -4 and 4, and we connect them with a solid line. Our interval notation, bracket, -4, 4, bracket. So what this means, and how this kind of ties into yesterday's lesson, is that absolute value inequalities are really compound inequalities. Less than inequalities are the AND version of our compound inequalities. Greater than or equal to are the OR version of our compound inequalities from yesterday. Okay, so let's apply those rules. It'll get a little easier, I promise you, as we do it. So we have our example here, case 1. We have greater than or equal to here. So let's graph, let's make two cases and graph. So first we have x is greater than or equal to 5. Now we apply keep it switch switch. X is less than or equal to -5. Okay, keep, switch, and then switch that sign. So we graph solid dot on -5, and that is our x is less than or equal to -5. I'm going to label that right here. And +5 to positive infinity. This is our x is greater than or equal to 5. And then let's write that in interval notation. Remember, we have, this is really, remember, an OR type of inequality. So we have negative infinity, comma, -5, and we need a bracket there, and we need the word OR. We need a bracket here, 5, comma, infinity with a parenthesis. All right, let's move on to case 2. So this time we've got a less than or equal to, and these will be of the AND type. So we'll have a connecting graph. So first let's make our two cases. Remember, as soon as absolute value is isolated, you make two cases. X is less than or equal to 8. Now keep it switch switch. X is greater than or equal to -8. So we've got -8, 8. Connect them with a graph. And let's write an interval notation. Bracket, because -8 is included, comma, 8, bracket. So, what do we say? What does this mean? It means that absolute value inequalities are really like compound inequalities. Okay, so our less than and our less than or equal to, those will be like the ands, and the greater than or equal to would be like our or type from yesterday. So let's review what we've done. Remember, the first thing, we have to isolate the absolute value expression. Then we have to make two cases. And for the second problem, remember, keep the variable, switch the inequality, switch the sign to set up the two cases. Then we solve both inequalities, graph the solution, and write the answer in interval notation. So that's what we're going to do here with these next problems. We're going to solve, graph, and write the solutions in interval notation. So let's get started. We'll do a couple, and then we'll see if you can do a few on your own. So we have the absolute value of x is less than 7. So we'll make our two cases. X is less than 7. X is greater than -7. So we'll write this in. We'll write our answer out. -7, we'll use that shorthand that we learned yesterday, is less than x, and x is less than 7. So we have open circle on -7, open circle on +7, and we simply connect them. We write it in interval notation, negative. So let me clean that up a little bit and write it a little neatly. -7, comma, 7, parenthesis. Okay, so let's go back to our notes. This is the and type, okay? Less than are like the ands, greater thans are like the ors. So that's the and type. We have a connected graph because let's just review something here. If we have x is less than 7, that would be this graph going to a negative infinity. That's x is less than 7. If we have x is greater than -7, that would be this graph going to positive infinity. That would be x is greater than -7. But the solution can only be the union of these two sets, which is this section here that I'm highlighting in yellow. So let's go on to the next one. We have the absolute value of x is greater than or equal to 4. This will be the or type. So absolute value, well, we separate, make two cases. X is greater than or equal to 4. Now we use keep it, switch, switch. And let's write our complete answer. X is less than or equal to -4. Let me just neaten up my work here. Or x is greater than or equal to 4. I should be boxing my answers for you. Let's do that now. Let's graph. We have solid dot, -4, because x is less than or equal to -4, but x is also greater than or equal to 4. And our interval notation, okay, we start with our parenthesis, negative infinity, comma, -4, bracket, or bracket 4, comma, infinity, parenthesis. So try 3 and 4 on your own. Take a minute and go ahead and try to do it. Remember, we're solving these absolute value inequalities just like we solve absolute value equations, but we're also layering on top of that the inequality rule. So try the next two on your own. Okay, let's see how you did. So let's make our two cases. X minus 1 is greater than 6. X minus 1 is less than -6. Okay, keep it switch, switch. So we add 1 to both sides on this first inequality. And let's add 1 to both sides of the next inequality. So we have, let's rewrite this. Let's start with our smallest value first. X is less than -5. or x is greater than 7. All right, we're going to have separate graphs here. So open circle, -5, x is less than -5, or x is greater than 7. Parenthesis, -infinity, comma, -5, parenthesis, again, parenthesis, 7, comma, infinity, parenthesis. How'd you do? Okay, again, let's make two cases. X plus 2 is less than or equal to 7. In our second case, x plus 2 is greater than or equal to -7. Let's solve those. We'll subtract 2 from both sides of the inequality. X is greater than or equal, is less than or equal to 5. And again, over here, we will subtract 2 from both sides of the inequality. X is greater than or equal to -9. We'll start writing with the smaller number. X is greater than or equal to -9. Oh, sorry about that. We have an and. We've got an and inequality here, and I almost wrote it in the wrong way. We start with the smaller number, -9 is less than or equal to x, and x is less than or equal to 5. This is our and type. So, because remember, if we're saying x is greater than or equal to -9, let's just take a look at the graph. Here's our -9. If we say that x is greater than or equal to it, then our graph goes out to positive infinity. However, we are constrained also by x being less than 5. So we're going to have to make some adjustments to that line. So we put a solid dot on 5, and we connect it. And let's write it in interval notation, -9, 5, both with brackets. Okay, so let's move on, 5 and 6. I would like you to try them on your own, and then we'll do them together. Okay, so let's solve these. 2x plus 5 is greater than or equal to 3. Now we do the second inequality. 2x plus 5 is less than or equal to -3. Remember, we already had absolute value isolated here. So we could go ahead and make two cases. Now, what do we have? Do we have an and or an or? Well, this is a greater than or equal to sign. So we're going to have an or. Let's go ahead and solve these. Let's subtract 5 from both sides. 2x is greater than or equal to -1, -2. And then we'll divide by 2. Should change the color to do that. Let's use a new color for that. Divide by 2, and x is greater than or equal to -1, because a negative divided by positive is a negative. Okay, on the next side, let's again subtract 5 from both sides. 2x is less than or equal to -8. And we'll divide both sides by 2. And x is less than or equal to -4. So, rewriting this, x is less than or equal to -4, or x is greater than or equal to -1. And we'll graph. So, x is greater than or equal to -1. Here's our -1, solid dot. And x is less than or equal to -4. Here's our -4. And our interval notation, -infinity, comma, -4, bracket, or bracket, -1, comma, infinity, parenthesis. Always use parentheses for infinity. Okay, now, before we can make two cases, we have to isolate the absolute value term. So we will add 1 to both sides. For absolute value of x plus 3 is less than 6. And this is of the AND type. We'd have a connecting graph. Now we can make two cases. X plus 3 is less than 6, or x plus 3 is greater than -6, and we'll go ahead and solve those. Add 3 to both sides, or I'm sorry, subtract 3 from both sides. X is less than 3. And here we will subtract 3 from both sides, but we will get a different answer. X is greater than -9. So -9 is greater than, less than x, because x is greater than -9. So -9 is less than x, and x is less than 3. So x will be all the values between -9 and 3. So open circles, -9, 3. We connect those. Interval notation, parenthesis, -9, comma, 3, parenthesis. Okay, looks like we have 4 more. I hope you remember that we do not distribute over absolute value. With absolute value, we will divide by that number outside the absolute value bars. And whatever we do to one side of an inequality, we do to the other. So now that we've isolated our absolute value, we have the absolute value of 2x plus 8 is greater than or equal to 30 divided by 3 is 10. Now we can make two cases because our absolute value has been isolated. 2x plus 8 is greater than or equal to 10. 2x plus 8, switch the sign. So this is going to be, we started out with greater than or equal to, so we will have an or inequality. Let's go ahead and solve these. So we will subtract 8 from both sides of the inequality. 2x is greater than or equal to 2. We'll divide both sides by 2. And x is greater than or equal to 1. Let's solve this one over here on the right, we'll subtract 8 from both sides. 2x is less than or equal to negative 18. And we divide both sides by 2. And x is less than or equal to negative 9. Let's write that together. So we will have, I'll change the color, we're getting a little crowded here. We will have x is less than or equal to negative 9, or x is greater than or equal to 1. Separate graphs. So x is less than or equal to negative 9. Here's our negative 9, solid dot. Graph going toward negative infinity. And our x greater than 1, here's our 1, solid dot. X going toward positive infinity. And our interval notation, parenthesis, always on negative and positive infinity, comma, negative 9, bracket, or bracket 1, comma, infinity, parenthesis. Okay, number 8. So we have a fraction in our absolute value. All we need to do is multiply both sides of the inequality by negative 2 so that we can isolate the absolute value term. So now we have the absolute value of 4x minus 8 is less than or equal to negative 6 times negative 2 is a positive 12. Now we can make two cases. So I'm going to write this up here and give us a little more room. So the absolute value of 4x minus 8 is less than or equal to 12. And this will also be of the OR type of inequality. So let's make some room down here, and let's go ahead and make our two cases. So 4x minus 8 is less than or equal to 12. 4x minus 8, nothing changes yet. Now switch the sign, switch the inequality and switch the sign. And now we'll go ahead and solve. On the left side inequality, we'll add 8 to both sides. 4x is less than or equal to 20. And we divide both sides by 4. And we haven't divided by negative, so we don't need to flip any inequalities yet. X is less than or equal to 5. On the right side inequality, again, we will add 8 to both sides, which gives us 4x is greater than or equal to negative 4. And we'll divide both sides by 4, which gives us x is, we didn't divide by negative, no flipping, greater than or equal to negative 1. So x is greater than or equal to negative 1, or x is less than or equal to 5. So we have a closed dot on negative 1, and x is less than or equal to that. A closed dot on 5, and x is greater than or equal to that. In our interval notation, we've gone from negative infinity to negative 1, bracket, or, and then our answer includes 5, comma, all the way to infinity, parenthesis. So, 2 left. Number 9. So let's add 3 to both sides, which gives us 10 multiplied by the absolute value of x minus 4 is greater than 50. And then we'll divide both sides by 10, which gives us the absolute value of x minus 4 is greater than 5. Let's make 2 cases. I think I'll change the color. So x minus 4 is greater than 5, then keep it switch, switch. X minus 4, we keep that whole thing, is less than negative 5, and we'll solve those. Adding 4 to both sides of the left side inequality, x is greater than 9. Adding 4 to both sides of the right side inequality, x is less than negative 1. So this is another OR inequality. We have x is less than negative 1, or x is greater than 9. So let's do our x is less than negative 1. Here's our negative 1. Open circle for less than, and showing that x, the solution goes all the way to negative infinity. And we need to add a little bit to this graph. Let's add a 9. Open circle, and all the way to positive infinity. Our interval notation, negative infinity, comma negative 1, parenthesis, or parenthesis 9, comma positive infinity, parenthesis. I know this last problem looks a little tough. What do we notice? We notice less than or equal to. So this is going to be an and inequality. Try it on your own. See if you can do it yourself, and then come back to the video. Okay, did you try it? How did you do? First, I want to subtract 11 from each side of the inequality. That will give me 1/2 the absolute value of 4x minus 4 is less than or equal to 15 minus 11 is 4. Now, guys, I know what you're thinking. Are you kidding me? I'm dividing by a fraction. Yeah, you are. Think about this. On this side, if you divide by a fraction, all you simply do is making that into 1, and you've isolated your absolute value term. When you multiply 4 times 1/2, what's half of 4? It's 2. So our final, so our isolated absolute value looks like this. The absolute value of 4x minus 4 is less than or equal to half of 4 is 2. Come on, guys, that wasn't hard. So let's do our rewrite. I think we have enough room to do this. We may have to change the color and write a little small. 4x minus 4 is less than or equal to 2. Let's make our second case. 4x minus 4, none of that changes, is greater than or equal to, what did I do wrong? 4 times 1/2. I know what I did. I divided when I should have multiplied. Oops. My bad, students. Small mistake. look what I did. I multiplied on the right instead of dividing. Let me get my color back. I'm dividing by 1/2. Still easy. Come on, guys. 4 divided by 1/2. 4 divided by 1/2. 4 times 2 over 1 equals 8. Okay? Okay, let's rewrite. Let's get back in business. Sorry about that. You guys know that I've been out for a couple days, so I'm just getting my math chops back. So here we are. Make two cases. 4x minus 4 is less than or equal to 8. In our second case, 4x minus 4, switch greater than or equal to, and it's negative 8. Now we add 4 to both sides. And 4x is less than or equal to 8 plus 4 is 12. Let's change color. We're going to divide both sides by 4. And x is less than or equal to 3. On the right side inequality, we'll add 4 to both sides. 4x is greater than or equal to negative 8 plus 4 is negative 4. So we'll divide both sides by 4. And x is greater than negative 1. So remember, this is an and inequality. So when we rewrite it, it's negative 1 is less than x. Remember, it says x is greater than negative 1. That means negative 1 is less. And then x is less than or equal to 3. So solid dot on negative 1, on 3. We'll connect them. Interval notation, negative 1, 3. And that's our 10 problems for today. But let's go back to our exit ticket. Absolute value inequalities are what? Absolute value inequalities are really compound inequalities. Less than inequalities are like the and type, and greater than inequalities are like the or type of compound inequalities. I don't expect you to get it the first time, but I do expect you to practice, and I know you will. So you do have a little bit of homework tonight. Make sure you watch the video several times, follow the rules, do your best work. Let me see if I can make a fall leaf. There you go. Keep practicing, students. You're hard workers, you're bright, and I know you've got this. And you'll be great.